Welcome to these lecture notes on gas laws. I'm going to be splitting this up into multiple smaller videos. The goal is to keep them between 5 and 10 minutes apiece. What we are going to be talking about in this unit is we're going to be talking about a couple of different variables that we use for gas laws, primarily pressure and temperature. We've already gone a little bit over temperature. We're going to use a new temperature unit. We're going to go over a little bit of kinetic molecular theory at the end. We're going to cover some different gas laws, and we're going to talk about some gas stoichiometry. My recommendation is that you listen to the entire lecture and then you go back and you pause the video and write down what you want from each individual slide as we're going. You are going to need a notebook. You may wind up needing a calculator and something to write with, so pause the video until you have those, and when you are ready, let's go. Okay, so the first variable I want to go over is pressure because that's one of the more important variables when we talk about gases. Gas particles are always moving, and when they're moving, they're always going to strike certain things. Now, whenever a gas particle strikes something, it exerts a pressure. Now, the formula for pressure is force divided by area. Right, so what we're talking about is we're talking about the force of the collision divided by the area of the collision. And there are going to be a bunch of different units that we're going to have to convert between. The basic idea to understand behind pressure is that it's determined by two things. First, it's determined by how frequently they collide, and it's determined by how hard they collide. Pressure is kind of an additive thing, so the more frequently gas particles can collide with the wall of a container, the higher the pressure on the container is going to be. And there are a bunch of different ways to accomplish this, whether you add more gas, whether you heat up the gas, whether you change the size of the container. All of those can affect the pressure. Now, the way that we go about measuring pressures. The tool that you see on your right is what's called a barometer. This was invented in the 1600s by a man named Torricelli. And basically the way that it works is that glass tube in the center is filled with a vacuum, and you place it inside of a dish of mercury. The atmosphere is constantly pushing down on all objects with a certain force. If you're pushing down on the pool of mercury, what that's going to do is it's going to force the mercury to go up into the vacuum tube. And all we do is we measure the height that the mercury's traveled in the tube. Now, normal atmospheric pressure, what we call 1 atmosphere, causes mercury to rise to a height of 760 millimeters. So one of our pressure units is 760 millimeters of mercury. Now, if the atmosphere is pushing down more, so the more the atmosphere is pushing down, the higher the pressure being exerted in this pool of mercury, the higher it's going to rise in the column. Right, so you're going to get a higher height. Now, like I said, there are a bunch of different pressure units that we're going to work with. There's no real one convention for it, unfortunately. It all depends on where you are and what your specific application is. The oldest unit is the millimeter of mercury. Again, this is measured from the barometer by Torricelli, and the torr, which is the same exact thing as the mmHg, just named after the person who invented it. The kilopascal is named after a physicist, Blaise Pascal. PSI is the American unit because, of course, we have to be different. We can't use an SI unit. We have to use our traditional unit, so the pound per square inch. Right, the pound is a unit of force, the square inch is a unit of area, so force divided by area gives us our pressure. And we have the SI standard unit, which is called the atmosphere, or ATM. This is basically the multiple of normal atmospheric pressure. So 1 atmosphere is 760 ATM, 2 atmospheres would be twice that. The following equation, or I should say equality, is something you definitely want to write down because this is how we're going to convert between all of these different units. So all 5 of these things are equal to each other. When you're going to do a conversion, just pick the 2 that you want. Right? Pick the one for the unit that you have, and pick the one for the unit that you're going to. So 1 ATM is equal to 760 mmHg, 760 torr, 101.3 kPa, 14.7 psi. Right, so let's do a couple of practice conversions. So the first one we want to do is 85.6 kilopascals to atmospheres. Right, so as always with any unit conversion, we are going to start off by writing down what we're given. So 85.6 kPa, put that over 1. Then I'm going to multiply that by my conversion factor. I want to be in atmosphere, I'm coming from kPa. The numbers I take from my equality says that 1 atmosphere is 101.3 kPa. kPa cancels. I set that equal, and then I plug that into my calculator. I'll give you guys a second for that. And we wind up with a value of 0.845 atmospheres for this pressure conversion. Now, again, whenever you see a math problem like this, what I would recommend you do is pause the video, try the problem yourself, and then once you have an answer, unpause the video, and that way you can actually see the solution and see if your answer differs. So we'll try another one. For this one, we want to convert 28.6 psi into mmHg. So again, pause, try it, and then unpause and see the answer. Okay, so our 28.6 psi is what we're starting with, so 28.6 psi. Our conversion factor, I want to be in mmHg, so I'm going to put that in the numerator. I'm coming from psi, so that's the denominator. The numbers here I write from the equality. The equality says 760 millimeters of mercury is 14.7 psi. psi cancels. I plug this into my calculator, so I multiply the numerator, divide by 14.7, and rounding off to sig figs, I'm going to get an answer of 1,480 mmHg. Right, so those are the pressure conversions. That's as hard as the pressure conversion is going to get, and you will have to do a bunch of these. Pressure is one of the most important, one of the 4 variables that you're going to need to do a gas law problem. Another one is temperature. Now again, we already know what temperature is. Temperature is just a measurement of kinetic energy, right? So in this case, it's measuring how much kinetic energy the gas particles have on average. The trick here is that we're not going to be using Celsius. We're going to be using Kelvin. The reason why is because Kelvin's set up with the lowest possible temperature being at 0. As it turns out, negative numbers really don't play well with gas law equations, so we can't use Celsius, especially when we're talking about things at low temperature. So we need to use Kelvin. The conversion is simple though, just add 273. Right? And again, all of our calculations will need to be done this way.